combustion reactions. Combustion reactions must have, what's it called whenever we add a carbon and hydrogen together? What kind of molecule is that? A hydrocarbon. A hydrocarbon molecule. It contains carbon and hydrogen. And what is a reactant? What does fire have to have? Oxygen. And oxygen as a reactant. It must also have carbon dioxide and what as a product? Water. Good, because that's what we saw. So a combustion reaction must have a hydrocarbon and oxygen as a reactant, carbon dioxide, and water as a product. We're first going to balance the carbon, then the hydrogen, and last but not least, the oxygen. If it doesn't work, then we're going to double all of the coefficients. So, for instance, if we get a decimal. All right, and this flame will help you understand combustion. The flame takes in oxygen and releases carbon dioxide and steam right there. So let's start by balancing this guy. How many carbons? So what do I need to put here? A 9. How many hydrogens? So what number needs to go here? 18 divided by 2 is 9. So we balance the carbons and the hydrogens. Now let's balance the oxygens. How many oxygens do I have here? 9 times 2 is 18 plus 9 times 1 is 9. 18 plus 9 is 27. So is 27 an odd or even number? Odd. So when we say it's odd, we're going to write that number down and double all the coefficients. Because 27 divided by 2 will give me 13.5, and there's that 0.5, so I have to double all of my coefficients. Okay? And we'll practice this more in class. All right, let's move on to notes number 2, chemical equation notes. You were introduced to this when we learned atomic structure. Remember Lavoisier? Okay, so the mole relationship which is our ratio between reactants or products, is determined by their coefficient. Let's highlight that. The mole relationship, which is a ratio between reactants or product, is determined by the coefficient. Very important to know. So, what is the mole relationship between carbon monoxide and iron? How many moles of carbon monoxide is there? 3. Carbon monoxide, there's a 3. So, remember we write ratios like that. How many irons are there? 2. So it's a 3:2 ratio. Right? So if 10 moles of iron is produced, so 10 moles of iron, how many moles of carbon monoxide would be needed? What did I do to 2 to make it 10? So this needs to be 15. So you would need 15 moles. Okay? Now you practice this one. Okay, so let's go back and review this. What is the mole relationship between carbon monoxide? We said it's the coefficient of 3, and that's where we got 3 from. And iron was 2. Okay, so that's where we got those coefficients from. All right, so practice. If 5 moles of iron to illuminate are produced, so 5, let's put a 5 here, 5 moles. How many moles of sodium chloride would be produced? I am so sorry. This needs to be a 1. because this is a 1 here. So it's a 1 to 6 ratio, yes? No. Yes? You see, it's a 1 to 6 relationship. There's 1 mole here and 6 moles here. So if the 5 moles are produced, how many sodium chlorides will be produced? 30. So the law of conservation of mass. We started this when we did atomic structure and we learned about Lavoisier. In all chemical reactions, the total mass of the reactants must equal the total mass of the products. And that's what my little picture shows you. Just because a chemical reaction has occurred and they've switched substances, there's still the balance is the same. So when 16 grams of iron 3 oxide, let's write 16 grams up top, reacts with 25 grams of carbon monoxide, 30 grams of iron is produced. How many grams of carbon dioxide are produced? These guys must be equal, yes? Because it says in all chemical reactions, the total mass of the reactants must equal the total mass of the products. 16 plus 25 equals? What is 16 plus 25? Good, 41. So therefore, X is what? This side must equal 41. So, 11 grams. Okay. Now you practice. When 85 grams of iron 2 chloride reacts with sodium aluminate, 35 grams of sodium chloride, and 75 grams of iron 3 aluminate are produced, or iron 2 aluminate are produced, how many grams of sodium aluminate were needed to react? Okay, so let's go over it. With 85 grams, so 85 grams reacts with the sodium aluminate, 35 grams of sodium chloride, and 75 grams of iron 2 aluminate are produced. How many grams of sodium aluminate were needed to react? So, 35 plus 75 is? Good, 110 grams. So this side must equal 110 grams. So 110 minus 85 gives me what? 25 grams. Final answer. All right, worksheet number 1.